Yes, good evening everyone. Please turn on your video.
Good evening, sir.
Yeah, good evening. Okay. First of all, we will understand what are the basics of circle, what are basic things in circle. You must be aware of it, but still I'll go give a quick revision of it. Okay. If this is a circle, you all know that this is the center of the circle. What is this? What do we call this as?
Radius.
Yeah,
Yes.
we call it as a radius. And what is this? The whole line?
Diameter.
Exactly. That will be a diameter. Okay. Then what is this?
Chord.
Yeah, this is said as a chord. And what is the what is this called as? This area called as? Yeah. See, the line is called as the chord. Okay, the line is called as the chord. The area under this is said as the segment.
Segment.
Okay, and there will be minor segment and major segment. That is, this part will be said as the major segment, and this part will be said as the minor segment. There are two segments. A chord divides a circle into two segments. One is minor and major. Okay, a diameter is a chord, or yes or no?
Yes, sir.
Yeah, all diameters are chord.
Yeah.
All chords are diameter.
Yes, sir. No, sir.
No. Okay, fine. So this is what the circle, center, chord, segment, and you must be aware about the sector also. If you have this
Yes,
as,
sir.
if this is a circle, okay, and if I draw lines like this, if suppose this is the center, and yeah, so what do we call this? This, if this is O, this is A, this is
Sector.
B, and C. Okay, so A, O, B, C will be what? It's a sector. This area will be said as the sector. And what will be this part will be said as? This part will be said as the arc of the sector, or you can say arc. Okay. Now you have learned this area of sector, area of length of arc and all. How to find?
No, sir.
No, sir.
Fine. So we'll be studying it afterwards. Now these were circles. Now what are concentric circles? If anyone knows.
Sir, the type of circles in which the center point is the same, but the size of the circle is different.
Yes. So as you can see over here, these are two circles. But if the two circles have the same center, if the two circles have the same center, then those circles will be said as what? Concentric circles. Concentric circles. There can be a set of three concentric circles or 10 concentric circles. It can be any number. Okay. Yes, Dhruv Parab, I will be sharing the notes of this class. Means if you are,
Okay.
yeah, I'll be sharing notes for all the classes which you take from me. All the notes will be shared. You only need to just remind the direction class team if you don't get it. Okay, I am going to send all the notes whichever
Okay.
class you attend. Okay, this is what your concentric circles, and the equal circles. What is circumscribed circle? What is circumscribed circle? Circumscribed circle. Fine. So what is a circumscribed circle? Suppose if you have a circle like this, okay, and if you have a triangle inside it, if you have a triangle inside it, so this circle is a circumscribing this triangle, right? Also, if you have a circle like this, and if you have a quadrilateral inside, okay, this is also what? Circumscribed circle, where it is circumscribing a quadrilateral. And any quadrilateral inside a circle which is circumscribed, those quadrilaterals are said as cyclic quadrilateral. They are said as what? Cyclic quadrilateral. You will be learning about cyclic quadrilateral in detail in your class 10. Okay?
Sir,
Yeah.
sir, so if in a circle, triangle, or quadrilateral, anything is there, it will be circumscribed. Sir.
Yeah, it's a circumscribed. It can be a pentagon, it can be a hexagon, anything. They all are circumscribed. Means this circle is a circumscribing a quadrilateral, a triangle, or a pentagon, or a hexagon, anything. Okay, what is circumscribing? That means it should touch the all vertices of the polygon. If a circle is touching all the vertices of a polygon, then it is a circumscribed circle. Got it?
Yes.
Next, what is inscribed circle? The next is, what is inscribed circle?
Sir, can I try?
Yeah,
A shape in which circle is touching all the corners of the shape.
all the corners of
All the sides of the shape.
yeah, all the sides of the polygon. Okay, when a circle is touching all the sides of a polygon, that means if you have a circle like this, okay, and there is a polygon outside, got it? This is what inscribed circle, where the circle is touching all the sides of a polygon. Over here, the circle is touching all the vertices of the polygon. Over here, the circle is touching all the sides of the polygon. This is called inscribed, and that is called circumscribed. With over here, the circle will be outside the polygon, and over here, the circle will be inside the polygon. Fine?
So is it possible for quadrilateral?
Yeah, yeah, it is possible for a quadrilateral also. See over here, I'll draw it. Suppose if you have a circle like this, and it can be a quadrilateral also, like this. Got it?
Yeah.
Yeah, it can be a quadrilateral also. Fine. Now the next. I have told you about what is arc, segment, and sector of a circle, right? The
Yes.
next is, yeah. The next, there are chord properties of circle and there are theorems into it. Okay, we'll be learning all the theorems one by one. Yeah, you will be having all the theorems in it. Okay, so the first theorem which you have is, the first theorem is a straight line drawn to the center of the circle to bisect the chord which is not a diameter is at right angle to the chord. Okay, these are theorems which you should be able to prove them. Okay, suppose if this is a circle, and what they have said, a straight line drawn from the center of the circle, if this is the center of a circle to bisect a chord. That means if you have drawn a chord, okay, this is a chord, and a line is drawn on it to bisect the chord, means I have drawn a line over here so that it should bisect the chord. Means it should, this line should divide this chord into two equal parts. Okay, which is not a diameter, is at a right angle to the chord. That means if I bisect the chord, what happens? That it will be at a right angle. That's what you have to prove, that it is a right angle. Okay, so in this theorem, what you have in the given and what you have to prove, we'll write it. If this is O, A, B, and this is C. So what is given? O is the center of the circle. Okay, AB is the chord. O is the center of circle. Okay, AB is chord. That's what is given. And OC bisects AB. That is what? AC is equals to CB. This is what all things you have in given. What you have to prove? What you have to prove in this? That is OC is perpendicular to AB. Is at right angle to the chord. That's what you need to prove. Yes or no? Got it? What you need to prove? Yeah?
Yes.
Yeah. Now let's do the proof of this. Okay. So now to do the proof, what we will do, we will join AO and OB, right? So to before doing the proof, you can you can write construction over here. What you can write the construction? That is draw join AO and OB. Fine. Now we'll write the proof. In triangle A ACO and triangle BCO. Yeah, in triangle ACO and triangle. Just a moment. Huh? Yeah, in triangle ACO and BCO. So what all things we can say? AO will be equal to OB. Can I say this? What would be the reason? Yeah, what would be the
Ma'am,
reason? Yeah.
sir, since that the O point is the center,
Hmm.
so AO and OB will be equal.
Radius, right? The
Yes,
reason is radius. Both are radius, no? So radius will always be equal. Yeah. Also, AC is equals to CB. That's given. Yes or no?
Sir, OC equals CO, common.
Common. OC
Yeah.
equals OC, you can see. That's common. So can I say that the two triangles are congruent by SSS test of congruency?
Yes, sir.
Yeah.
yes,
Therefore, triangle. Well, I'll take this circle over here. So I can say that triangle ACO is congruent to triangle BCO by SSS test of congruency. So after this congruency, can I say therefore angle ACO plus is equals to angle BCO?
Yeah.
Yeah,
yes,
by CPCT. They both are equal. But what I know, angle ACO plus angle BCO will be equal to how much?
180.
180
180
degree.
degree
Why? Linear
Linear.
pair.
linear.
But they both are equal. So what I can say, angle ACO plus angle
90
ACO
plus 90.
is equals to 180 degree. So twice of angle ACO will be equal to 180 degree. And finally, I can say that angle ACO is equals to 90 degree. And that's what your proof. So you can say hence proved. Hence proved. You can also say over here, therefore, AC is perpendicular to OC is perpendicular to AB. Therefore, OC is perpendicular to AB. And over here, you can say right over here, hence proved. Is that clear? The next theorem which you have is, it is only the converse of this. What you have, a perpendicular to the chord from the center of the circle bisects the chord. Now what they have given, just the reverse of this. Now the line is perpendicular to the chord, you have to tell that it is bisecting the chord. Before this, what we had, it is bisecting the chord, then prove that it is perpendicular. Right? Now what is given? It is perpendicular, you have to prove that it is bisecting the chord. So the same way you will have to do, again the same two triangles, I'll give you a short, in short, how you can prove it.
Sir, we have to prove the triangles to be congruent and then we can do CPCT.
Yes, the same way. Yeah? So we'll go to the next proof. Should I go to the next?
Yes, sir.
Or after proving
Yes,
triangles congruent, we can say that both it
Sides are,
divides the
yes, it's
side
the
to
two sides are equal. See, I'll explain
yeah.
you on this diagram only. See, on this diagram, it is given that this is 90 degree. Okay, it is given that this is 90 degree. You'll have to prove that the two triangles are congruent. Once you prove that two triangles are congruent, then AC is equals to CB, and that's it. That's where it's bisecting the chord. Got it? The same process
Yes,
you have to do. Got it, no? Okay, the next one. Now the next proof which you have is this. Equal chords of a circle are equal distance from the center. Okay. Now let's draw a circle to prove it. Okay. Now let's say this is the center of the circle. Now equal chords of a circle means there are two chords which are equal in distance. Okay. Suppose if this is one of the chord and this is another chord, but both the chords are equal in length. That means if this is AB and this is CD, what is given in this? That is AB is equals to CD. That is given. The two chords are equal. Are equidistant from the center. That means are equidistant from the center. That means if I draw perpendiculars to this chord, now what you have to prove in this? To prove is if this is ABCD and this is E and this is F, what you have to prove? You have to prove is OE is equals to OF. They both the chords are equidistant from the chord. See a distance of a line from the point. How you take a distance of a line from the point? See if you have a line over here and if you have a point. And if I ask what is the distance of this line from this point, how you'll find? You'll find this distance or this distance or this distance. Which distance you will do?
The perpendicular distance.
Yeah, the perpendicular, because that will be the shortest distance of the line from the point. Okay, so the distance is always perpendicular. Yeah, the distance is always perpendicular in this case. Okay, so OE is equal to OF. Fine. Now what you have to prove in this? That is to prove is OE is equal to OF. That's what you need to prove. Now to prove it, we will have to do some construction in it. Okay, the construction, what you have to do is you can join AO and OD. Join AO and OD. Fine. If I join AO and OD, see what happens. Okay. If I join AO and OD, now the proof. The proof is in triangle AEO and triangle AEO and DFO. Yeah, what you need to prove? That is OE is equals to OF. Yeah, in this triangle you have to prove that. Now over here AO is equals to OD. What is the reason? Radius.
Radius.
Yeah, let's take this circle down. Wait. Yeah, AO equals OD. Why? Because it's a radius. After that,
A
angle.
equal to F.
Why? What is that?
Sir, AE equal to FD.
How?
Sir, AB is equal to CD. So
Yeah, right.
half of it.
Yeah. Why? We have to mention it first. So we know that AB is equals to CD. That's given. Yeah. So half of AB is equals to half of CD. So, since it bisects the chord, we know that. So half of AB will be AE and half of CD will be how much? FD. Got it? So in this triangle, AE is also equals to FD. We got this. Now the next which you have to prove is we can also say that angle AEO is equal to angle DFO. Why? Each 90 degree. Yeah. Each are what? 90 degree. Then can I say that the two triangles are congruent? Therefore, triangle AEO
Yes, sir.
is congruent to triangle DFO. Yeah. Now, if the two triangles are congruent, so can I say,
Sir,
yeah,
sir, by which test?
acha, by which test? We will have to write by, there is one angle, okay, this side and this side. So this,
SSA.
no. It is hypotenuse side
Sir,
test.
RHS.
Yeah. That is RHS, by RHS test of congruency. Yeah, I can say by RHS test of congruency. Now, if the two triangles are congruent by RHS test of congruency, therefore I can say OE is equal to OF by CPCT, and therefore what we can say, the two chords, the two equal chords, are at equal distance, from the center. Got it? And you can write over here, hence proved. Got it, everyone? How many of you have understood?
Yes,
Please raise your
sir.
hands. Fine. Next. This is done. Now the next theorem which you have. See, in all the theorems, most of the time you have to prove that the two triangles are congruent and the two distances are equal. That's it. You only keep it in mind for any theorem you want to do. You have to prove that the two triangles are congruent. And you have to prove it. You have to prove that the two triangles are congruent. That's it. Okay. Now again, the next theorem which you have is just the converse of the same. Okay. This is just the converse of it. What you have? Chords of a circle equidistant from the circle are equal. What they are saying? If there are two chords which are equidistant from the center, that means the two chords are equal in length. Understood?
Sir, what we have to find out?
Means this is again a theorem. Again a theorem. You have to find out, means you have to prove that the chords are at equal distance. See, again the same
Okay,
thing.
sir.
See what you
Can
have
I
to do.
explain in short?
Yeah, wait. See, I'll explain you what you have to do in this. See, again what you have, now the distances are equal. You know that OE is equals to OF, that is given. Okay, that will be given. You have to prove that AB is equals to CD. So what you will do, again the same thing you will do, that the two triangles are congruent. Once the two triangles are congruent, what you can say, AE equals FD. We know that if AE equals FD, we know that AE is twice of half of AB. So after that you have to equate and you will get that AB is equals to CD. That's it. And there the chords are equal. How many of you have understood? Please raise your
Sir,
hands. Yeah.
so for proving the triangles congruent, we can take AO equal to DO and EO equal to FO. And
Yeah.
third thing, what we can take?
Third thing will be the right angle. If you draw a line, means if you are taking a distance from the chord, that will be perpendicular only, no?
Yeah.
Yeah, the line which you draw will be perpendicular only. Therefore, the angles will be 90 degree only. Understood, everyone over here? Yeah? Okay.
Yes.
Yes, sir.
Okay, fine. Now the next we will do. Okay. Now what you have? A chord of length 6 cm is drawn in a circle of radius 5 cm. Calculate its distance from the center of the circle. That's all. It's a very easy question. Once you understand, it's very easy. Okay. See over here. If I draw a circle in it, okay, I have drawn a circle in it, okay, and this is the center, okay. What you have, a chord of length 6 cm is drawn in a circle. That means I have drawn a chord of 6 cm. This chord is of 6 cm and is drawn in a circle of radius 5 cm. That means the radius of the circle is 5. The radius is 5. This is 5, this is 6. You have to calculate its distance from the center of the circle. What is the distance of this chord from the center? That means if you want to find what is the distance of this chord from the center, that means you have to draw a perpendicular line on it. So that will be the distance. We know that any line, means if you draw, this will be right angle. Yes or no? And if this is 6, this bisects the chord. So this value will be 3.
3.
If this is 3, this is 5. By using
Sir,
Pythagoras, you will get 4.
Pythagorean theorem.
Yeah.
Pythagoras theorem.
Yeah, by Pythagoras you'll get that this is 4. Therefore, what we can say, the distance of the chord from the center is 4 centimeter. Got it? You can just show the normal working in it. Yeah, clear everyone? The second question is just the same. You use the Pythagoras, you'll get the answer. Okay? A radius of a circle and the length of the perpendicular drawn from its center of the chord. Calculate the length of the chord. The same thing. Yeah. Please solve this question and tell me what it will be. What will be the answer? Please tell me. You have to give your answer personally to me and in the chat box.
Sir, the third one.
Yeah, the third one you have to do.
Okay.
Sir, these questions are given in the textbook.
This questions are from Selena, Concise Selena book. Yeah. Fine, I will solve it because I did not get answer from all of you. I got answer from only 3 or 4 students. Fine, see over here. It's a very easy question actually. What you have a circle. Okay. And the radius of the circle is 17. Fine. If I draw this radius of the circle, the radius of the circle is 17 they have given. This radius is 17. And the length of the perpendicular from its center to the chord is 8. Means if I draw a chord to it, if I draw a chord to it, now what you have? And the length of the perpendicular from the center, from its center to the chord is 8. Means this length is 8. Calculate the length of the chord. You need to find what is length of chord. So using Pythagoras, you can find what is CB. If you use Pythagoras, 8, 15 and 17 are the Pythagorean triplets. Okay, if you use the Pythagoras, you will get CB. That is easy for you, right? Everyone. Yeah. So once you get what is
Yes, sir.
CB, after that AB will be just twice of CB, that is 30. So the value of the chord will be 30. Is that clear to everyone? Please raise your hands if it's clear to you.
Yes, sir.
Can you explain a bit?
Can you explain or can I explain? What did you say?
Sir, can you explain?
Acha, okay, fine. Who was this?
Sir, Julie.
Okay, Juhi, fine. See over here. They have given the radius of the circle is 17. So I have drawn this 17 as the radius. Okay. After that, and the length of the perpendicular drawn from its center to the chord. Means if you draw a perpendicular to the chord, that the length of that is 8. Yeah. And then you have to find what is the length of the chord. Fine. So this is perpendicular, no? So you can use Pythagoras. See, if you use Pythagoras, what do you know? That is OB square equals OC square plus CB square. You need to find CB.
Yeah.
CB square will be equal to OB square minus OC square. OB 17 square, 8 square. What is the value of 17 square?
289.
218.
Sir,
Yeah.
in the same sum, if we consider AO as 17 and solve, then the answer will be same, right?
Yeah, obviously. The two triangles will be congruent
Okay.
only, no?
Sir, because I solved like that, that's why I
Yeah,
asked.
no problem. No problem. It will be same. Yeah.
Okay, sir, thank you.
Yeah. Welcome. Fine. So this is 289 minus 64. So if I solve this 9 minus 4, that is 5. 8 minus 6 is 2. And this is 2. So CB square is 225. So the value of CB will be
15.
15. So once you get the value of CB as 15, the value of EB will be 30. Juhi, that's clear?
Yes.
Yeah?
Yes.
Okay. Fine.
Sir, using congruency, how to solve?
Not using congruency. You don't have to use congruency to solve. Shubhangi was asking that if I use this triangle, then is that fine? She was asking. So if you use this triangle or this triangle, both are same triangle only, no?
Yes, sir.
That's what. Okay, fine. Next. Chord of length 24 is at a distance of, and find the length of the chord of the same circle which is at a distance of, wait, a chord of length is at a distance of 5 from the center of the circle. Find the length of the chord of the same circle which is at, yeah, let's solve this question number 4. You want to try? I'll give you 1 minute to solve. Take a try.
Yes, sir, we will try.
Yeah, you can take a try. See over here, what you have, a chord of length 24 centimeter is at a distance of 5 centimeter from the center of the circle. So let us draw the circle first. A chord of length 24 centimeter is at a distance of 5 centimeter from the center of the circle. Fine. This is 24. Okay, chord length is 24. A chord of length is at a distance of 5 centimeter from the center of the circle. So this distance from center, distance from the center is how much? 5. Find the length of the chord of the same circle. Now you have to find the length of the chord of the same circle which is at a distance 12 centimeter from the center. Means if this is a chord and this chord is at 12 centimeter from the center. So what will be the length of this chord they are asking? Fine. Now to find this, what we will do, I can draw this radius for both the triangles. Fine. This will be perpendicular for both because these are the distance from the chord. If this is 5, this is 24, this will be 12. And if this is 12, by using Pythagoras triplets, this will be 13. If this is 13, this will be 13. And if this is 13, this is 12. By using Pythagoras triplet, this will be 5. And if this is 5, the whole is 10. Is that clear? You cannot write by Pythagoras triplet. You have to solve it. Yeah? I hope you are aware how to solve that Pythagoras triplet. Means you just,
Yes, sir.
yeah?
Yes.
Yeah? Is that clear to everyone? Please raise your hands. How many of you have understood everything?
Sir,
Yeah.
so that second chord that will be 12 centimeter from the center. How means both they will join?
Okay. This was Juhi, right? Juhi, you asked this question.
Yeah.
Okay. So what you are asking, please ask it again.
So the second chord when we join it,
Wait, I'll
how
I'll
both
I'll
will
I'll,
be
I'll write the
different?
values over here. O, B, C, D, E, and F. Yeah, what you are asking?
So how EO and OF are meeting at center means both values are
O, E, and O, F. See, both are distance from the center, distance of the chord from the center. Both are what? Distance of the chord from the center. Whenever we find the distance of a line from the center, that means that distance is always perpendicular to the line. See, if I have a line and this is a point, if I say, what is the distance of this line from the center, you will always take this distance. And whatever the distance is mentioned, that will be always perpendicular, no? Got it? Why they are perpendicular?
yeah.
Did I cleared your doubt? You still have any doubt? You can ask.
No.
No? Sure? Okay. Now I'll go to the next question. The only same thing you have to use Pythagoras, you get it. You'll get it. Draw two circles in your notebook. Do not try to draw everything on the screen. Means solve everything on the screen. Yeah, try drawing the two circles and write the distances which you have on your notebook. Then see to it, you will be easily getting it. Okay. I did not get answer from everyone. Fine. See over here, I'll solve it. Means I'll solve in a short way. You should be able to understand it. Yeah, what all things they have given. This OA is 34. This value is 34. After that, OB is 20. This value is 20. Yeah. And then OP is 16. This value is 16. And find the length of AB. You need to find what is this length of AB. This is what you have to find. So it's very easy. That is, this radius is 34 and this 16. So you can find AP by using Pythagoras. Okay, by using Pythagoras in triangle APO and this. Using Pythagoras, you will get the value of AP. So using Pythagoras, the triplets are 30, 16 and 34. So the value of AP will be 30. Okay, I'm solving just because I remember the values of triplets. Okay, and after that, this triangle is also what? A right angle triangle. This is 20, this is 16. Then what will be the value of BP? Again,
12.
Pythagoras triplet, that is BP will be 12. I hope everyone is understanding how to find these values. Yes, Juhi, that's clear, no? How to solve
Yes, got
Pythagoras. You are learning Pythagoras from, I think, class 6th or 7th. I will not be teaching you that. Yeah? Okay, fine. So if this is 30 and this is 12, just subtract them. AP minus BP will give you the value of AB, and that's 18. The value of AB will be what? AP minus BP. So that is 30 minus 12, which gives you 18. Is that clear to everyone?
Yes, sir.
So Jui, why you are getting where you are getting a wrong answer? Where you was doing wrong?
it. Actually, I thought that AB and BP were equal, so directly wrote 15.
Oh, it cannot be equal. Yeah, they are concentric circles. You can say BP and PC are equal. Okay. See if the circle is just very near to it. So can it be equal? It cannot be equal. Yeah. Fine. Next, we'll do the next one. Now over here, what you have in a circle of radius 17 centimeter, two parallel chords of length this and this are drawn. Find the distance between the chords if both the chords are on the opposite sides of the center or on the same side of the center. I will solve this question. What they have given
Sir,
in a
can we try?
uh okay, try it. See, I'll give you a small hint to solve this question. Means if this is a center, if they say same side of the center, that means the two chords are on the same side. And if they say they are on the opposite side, that means one chord is on this side and the other chord is on this side.
Sir, no, wait.
Okay. I know you were stuck in this only because that was the only new thing.
Sir, is the first answer I sent correct?
Okay, let me check what is your answer. No,
Sir, so for this, two circles will be there, no?
no, there will be single circle. See over here, I'll solve it. I'm not getting the answer and not expected to get the answer also because it's a new for you. Fine.
Sir, can I send the first answer? Like the
Yeah,
distance
why not?
between the
Why not?
chords?
Why not? You are allowed. Always allowed. You can send the answers. Okay. Still it is you are close to the answer, but on the you have to find the distance between the chords. Your answer is
Oh, sir,
almost right.
I found the center to chord.
Yes, 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 yes. You are almost there for the answer. You just have to add and subtract. You will get the answers. Okay. Now over here in a circle of radius 17 centimeter, two parallel chords of length 30 and 16. Means one chord is of 30 and the other chord is of 16. Fine. I will draw these two chords. Now, suppose this is 30 and this is 16 and the radius of the circle is 17. Fine. If this is the center, the radius of the circle is 17. Got it? The radius is 17. What you need to find? You have to find the distance between
Distance
the,
between them.
yeah, you have to find the distance between them. That is, if this is right angle and this is also right angle. So just you have to use the Pythagoras. If this is 8, this is 17, so this will be how much? Yeah, this will be 15 using Pythagoras. Got it? Similarly, if this is 17 and this is 15, so this will be 8. So the distance between the two chords is what? 15 plus 8. That is how much? 23.
23.
And if the two chords are on the same side, that means what? See over here. If the two chords are on the same side of the circle, then the circle is like this, and the two chords are like this. Means one of the chord is this, and the other chord is like this. Means the two chords are on the same side of the center, and this is the center of the circle. Okay, and if I draw lines like this, okay, if I draw lines like this, yeah. So if they are on the same side of the circle, then what will happen? Now this is 8, so this is total is 16, so this will be 8, and this is 17, and this whole length is, this will be 15. Okay, and this is 17 again. So if this is 15, this is 17, this will be how much? 8, and this is 17, and this is 8, this will be, the whole will be 15. Okay, so the distance between the two chord is this length, that is 15 minus 8. So whatever you get, that is 7. So that is the distance between the two chord. How many of you have understood each and everything in this sum? Please raise your hands. Juhi, Shadan. Do not raise your hand just for showing it to everyone that I also understood. You have to keep your, do not raise your hand if you do not understood. You can ask. Riva, you want me to explain?
I didn't understand.
Okay, fine, no problem. So Riva, please tell me which part you did not understood.
Sir, when you said that it is 7 centimeters.
Okay, there is 7 centimeter. You have understood this part?
Yes, sir.
Okay, fine. Now in this part, see, if I say this is O, this is B, and this is C. What is the value of OC? The value of OC will be 15. And what will be the value of OB? That will be 8. Is this clear, Riva?
Yes, sir.
Okay. And what we need to find the distance between the two chords, that is BC. So if I want BC, the value of BC will be OC minus OB. Yes or no?
Yes.
The value of OC is 15 and the value of OB is 8. So the answer is 7. Now is that clear?
Yes, sir.
Okay, that's it. Yeah. So if anyone is not understanding, you should not raise your hand or you can ask the doubt. Okay. And get the clarification why you are into the live class. You can also attend any recorded sessions. There are a lot of recorded sessions available, right? You are in a live class. Why? Because you should be asking doubts, you should be interactive while the class is going on. Okay? Fine. Next. Over here, two parallel chords are drawn in a circle of diameter this. The length of one chord is this and the distance of the two chord. And the distance between the two chord is this. Find the length of the other chord. Please try it on your own. The two chords are drawn, the length of the two parallel chords are drawn in a circle of diameter this. The one chord is, and the distance between the two chord is. Yeah, please try. See, this is a circle. Two parallel chords are drawn in a circle of diameter 30. The diameter of the circle is 30 and two parallel chords are drawn. But currently I don't know whether they are on the opposite sides of the center or on the same sides of the center. I don't know that. I will just consider they are on the opposite sides of the center. Okay, I'm just considering. Still, I am not sure which one is right. Okay, the length of one chord is 24. The length of one chord is 24 and the distance between the two chord is 21. Now, since the distance between the two chord is 21, So tell me whether the two chords are on the opposite sides or on the same sides of the center.
Sir, opposite.
Why?
Opposite.
Sir, because the number is very big as compared to the size of the chord.
Size of the no.
So radius of
Yeah,
circle.
yes. The radius of the circle is 15, right? So if the distance between the two chords is greater than 15, that means the two chords are on the opposite sides of the center. Okay, so whatever we have considered, that's right. And what did they say? That the distance between the two chords is 21. This total is 21. And there is a center over here. This total, if I say this is A, B, D, O, E, and F. What I know, that is the value of EF is 21. Find the length of the other chord. We know that the radius of the circle is, what will be the radius of the circle?
15.
15. So I hope you will be able to solve it now. Now all the confusions are clear, Shadan?
Yes, sir.
Okay, please. I am expecting an answer from you. Yes. Anyone else? Ritika, yes, your answer is right. Very good. Yeah. So tell me, what is the value of OE if you solve by using Pythagoras? 15 and 24, what will be this length?
9.
This will be 9. And if this is 9, this is also 15. And we need to find what is CD, right? Um, the total length was given, EF is 21. So 21 minus 9 will be how much? Will be 12.
12.
And if this is 12, this is 15. This will be how much? This will be 9. And if this is 9, the whole length will be 18. Clear? Is there anyone over here who did not understood this?
Sir.
Okay then, so over here we are done for today and bye. Have a good night.
Thank you, sir.
Yeah, bye.